Okay guys, let's get into understanding the relationship of Ecell and Gibbs energy. Alright. Now prior to that, let's get into work. Alright, mechanical work. Now mechanical work, we know if suppose this is one object which has to be shifted from here to here. Now suppose if we apply force in this direction and shift it from here to here at this place, the displacement being S, then work would be force whatever we are applying into S, that would be work. Force into displacement would be work. Now I am applying force at an angle theta. Alright, this is the angle at which I am applying force. This was F, so this component is F cos theta. So the work would be F cos theta into S. We know dot products and cross products. Now we know that A cross B is equal to AB sin theta, which is a vector. And at the same time, we also know A dot B is equal to AB cos theta, which is a scalar. Now here what we get is Fs cos theta, if we want to say it that way, is then. Now if it is cos theta, that itself means that it's a scalar quantity too. So from this we get an idea that work is a scalar quantity. Okay, this was just to refresh mechanical work when force is applied at an angle to the distance, alright, and also whether it is vector or a scalar. So we got to know that work is a scalar quantity. Okay, now let us come to electrical work. This was mechanical work. Now let's get into electrical work. In electrical work, what is the formula for work? Formula for work is amount of charge into cell potential. And amount of charge is Q and cell potential is E, which we have seen already. And we also know this relationship, which I had told you earlier. 1 mole corresponds to 96500 coulomb, which corresponds to 1 Faraday. 1 mole of electron corresponds to 96500 coulomb, which corresponds to 1 Faraday. Okay, so if n moles of electrons are passed, then obviously it would be nf coulombs. Alright, now so let's get back to the formula. So this is what? Nf. So now right now amount of charge passed is Nf. So formula for electrical work would be Nf Ecell. Alright, so this becomes the electrical work. So what does electrical work do? Since electrical work decreases Gibbs energy, therefore electrical work would be equal to minus del G. Negative because it decreases work. Alright, so or del G is equal to minus NF E cell. Alright, or standard del G is equal to minus NF E0 cell. So this is the formula that we have derived for change in Gibbs, standard change in Gibbs energy, and this is change in Gibbs energy. Alright, relation between change in standard Gibbs energy and equilibrium constant K is del G0 is equal to minus RT ln K. Instead of del G0, we obviously can substitute this. So we substitute over here. So the relationship is like this. Or if we just want to determine E0 cell, so I take NF below. So it becomes RT over NF, where we know F is Faraday and is number of electrons involved in redox reaction, and K is equilibrium constant. Alright, so substituting all those values there for F, R and T, since it's standard, so we know gas constant, temperature 25 degrees Celsius, and Faraday 96500 coulombs. So on substituting all those values, this is what we end up with, which we have seen earlier also. So 0.0592 divided by n log K to the base 10 at 25 degree is our final formula for Ecell. So knowing equilibrium constant of a particular reaction, also knowing number of electrons involved in redox reaction, we can find E0 of cell. Yet another methodology to find value for E0 cell. So understand it would be applicable for numericals. Alright, see you then.